Okay, so all right. So let's start with tutorial 3, and then if we have time, I'll go back to the last question from previous tutorial. So question number 1 is asking if the systems shown here are linear or not. Do you remember the method to check the linearity? We talked about it last week. So what you do is, so I would say that's my xt going into my system, and that's my yt. Now, step 1 said consider AX1T. So a new input signal is the same as the original one multiplied by A, which is sent into the system, and you will get an output. I'm going to call it Y1. And then send another signal, this time multiplied by B, the same input, and then I call it Y2. And then add these two, so you have Y1 plus Y2. Okay? So that was step 1. AX1, BX2, send both to the system, add the outputs. Now step 2, this time send or add inputs first, AX1 plus BX2. Send it to the system. So the only thing which differed was adding them at the beginning rather than waiting for the outputs and then adding those. And then you have Y3. If Y3 is equal to Y1 plus Y2, that's linear. Now, I keep the same page because I want to refer to this page. I'll quickly go back to see the first system is yt is xt minus 3. So xt minus 3. So all this system does is deducting 3 from your input. Now, let me use another color. Okay, now what happens if I send AX1T to the system? What comes up? AX minus 3. That's correct. So what comes out is AX1T minus 3. Remember, all this system does is subtracting 3 from your input. So I'm sending AX1T to the system. All it does is subtract 3 and gives you the output. Now, if I send BX2 to the system, what it gives me is BX2 minus 3. If I send the lecturer to the system, all it does is deduct 3 from the lecture. So you don't forget. Okay? So it doesn't matter what you send to the system. Whatever is defined will be implemented on the input. Now let's add them. The answer will be ax1 plus bx2 plus 6, right? Minus, sorry. Right? So step 1. Step 2. Let's send ax1 plus bx2 to the system. What does this system do? Come on, think about lecture. Exactly. Whatever you send to the system, 3 will be deducted. So I keep whatever I sent minus 3. Remember? That's what the system does. Xt minus 3. It's what the question's telling me. Output is xt minus 3. That's what your system does. Now, it's time to check. Are these equal? No. Then this is not linear. Raising hand. Who didn't get this? That's good, because you're going to solve the second one. Are you done writing? Yep. Okay. Just give you a few more seconds. You good? All right. So, yt equal to t square xt. Grab a piece of paper. Find if this is linear or not. Okay, second one. And do not look at the solution. It's already available on Canvas. But just try to solve it yourself. Believe me, that's the effective way of learning. You good, Mohammed?
Yeah.
Yeah? How many units do you have this semester?
Just 4.
Just 4?
Yeah.
4 is a lot. It's not just 4.
It's
You should
normal, no?
you should say 4.
Okay,
No.
4.
Just is for like 2 units. Just 2. So what this system does is whatever you send to the system, it squares, finds the time, squares it, and then multiplies it by it. So think about that. Find the time, square it, multiply it by whatever you want to send to the input, send to the system as the input, that will be your output. And then I'll go back to this page so it helps you. Just follow the blue lines. The system is t square xt. Who said that? Come to the board. Come on. It's easy. Believe me. It's 3 marks. 3 bonus marks. Come. It's t squared xt.
Is it like this?
I'll just solve it. That's fine.
And you just check.
Yeah, go for it. Come on. It's fine to make mistake. It's tutorials. The important thing is not to make a mistake in the exam. Okay, I'm gonna sit here. It's a bit difficult in general, the unit, because it has a lot of math.
Right.
And then it's like bits and pieces from different topics of math, like we have differential equation, then we have logarithm. Press ESC, yep. Thank you. Something that confuses students, yeah, that was correct. Send me an email with your name, would you? Okay, so what confuses most students is that they focus on just finding y and x, okay? Well, if you do it the way I did it, focus on output and input, okay? Just at the beginning, think what happens when you send something into the system, okay? Then you won't make a mistake. So instead of looking at that t squared xt and try to find the answer, just at the beginning, see what your system does. So the system, whatever you send it to, is turned into t squared times that input. So if you form the input, you will not get confused. Whatever you send to the system, just multiply it by t squared. That's all. So at the beginning, we send ax1, a t square is multiplied by it. We send bx2, a t square is multiplied by it. And then add these two. Then send ax1 plus bx2, a t square is, so what I'll do is one step before here will be t square times ax1 plus bx2, right? Because that's what's sent to the system multiplied by t squared. And then it will be t squared ax1 plus t squared bx2, which is equal to what we have on the at top. And then it's linear. Raising hand, who didn't get this? All right. Okay. Solve the third one. Fourth one. Yt is equal to x minus t. So can someone tell me what this system does? Just flips. whatever you send to the system, it will be flipped. There was an issue with the 6160 Canvas side. I couldn't upload the recordings, which was resolved today, and I uploaded the recordings this afternoon. So you should be able to find them under modules. So check module 2 and 3. The recordings of this year should be there, and the recordings of 2 years ago, 2022, previous lecturer, it's also there. In case you prefer hair over me, so just watch hair lectures. Do we have a volunteer? You just go for it. This is something you should find. Okay, I'm gonna sit. What's your major? Electrical power.
The challenge that I believe is I was doing 8 and 6. So I was working with Rio Tinto in the mine.
Okay.
And that I resigned. So
Oh, you resigned?
Yesterday was my last day.
Okay.
Because I was behind.
I see.
Yeah,
Was it this unit or the unit?
all the units.
Okay.
Yeah, because I would only get enough time when I'm off.
Of course.
Yeah,
Of
and
course.
then we work 12 hours there.
I understand. Yeah.
Back from work, you want
Yeah.
to sleep.
No. Is it 6 to 6, right? 6 a.m. to...
Yeah, 6 to 6.
Yeah.
Yeah, so, yeah, sometimes it's not about money.
I understand. No, definitely. No, definitely after 12 hours of working, yeah, it's difficult to do anything other than just resting.
So I need to catch up with this. What you are saying is clear, but sometimes if you're not read with the stuff,
I
you
understand.
don't understand.
Yeah, I understand. And especially this unit, so everything is like a building. So lectures are connected, and so and especially the first few, like the first 4 or 5 lectures, they will be used for the second semester. So,
Yeah, so that's why I decided to just
Yeah.
resign, and then so here in Perth, I'm just looking for a job where I
Yeah.
work night shift only.
yeah,
And then I
yeah,
come to school
Yeah.
during the day.
yeah. Hopefully, you'll find something soon.
Yes.
Yeah. So you're supposed to be a lecturer. So you're solving it for yourself.
Like this, taking it common here.
Can I have a look? Sorry.
Here in the system for A and B.
Oh, no. The reason is, see, if you go back to, can I write something here for you?
Sure.
If you go back to, I think it was lecture 2, okay, we talked about time shift. Sorry, time and amplitude. Okay, so xt and x minus t and minus xt are totally different. So if you have this 0, 2, and that's 1, x minus t will be flipping it. This will be x minus t, while minus xt is this. Okay?
Thank you.
No worries. All right. Oh my God. So the emphasis is on having a linear system. Okay. So there is no control. Oh, yeah, there is. Okay. So I just. Okay. No, the solution was correct. All I'm trying to do is just quickly going through it again. Okay. Now, again, think about what your system does, turning all the t's into minus t. Okay, that's all it does. It's flipping. Now, if I send ax1t, all it does is changing t to minus t. It will be ax minus t. And then if I send bx, it will be bx minus t. So it doesn't change anything but t. And then you add them, what you will have is ax1 minus t and then bx2 minus t. And then here, I'll send ax1t plus bx2t. And then what I should get is the same, but with minus t. Right? And then these two are the same, so it's linear. Now, your friend asked me a question, which I think was a good question. What happens if I have yt equal to minus xt? Yeah, it does, but in terms of linearity. Why? Yes, because see, all it does is it gets your input multiplied by minus 1, right? Now, if your y is minus xt, if I send ax1 to the system, what I get is minus ax1. Then I send bx2 to the system, what I'll get is minus bx2. And then if you add them, what you will get is minus ax1 minus bx2. Now, if you send ax1 plus bx2 to the system, what you get is minus ax1 plus bx2. So anything you send inside a minus sign is added to it. Now, what if I put 1 here? So y is minus xt plus 1. Yes? Why not?
Because it stopped.
No, you cannot tell. Sorry? It's not linear. My question is why?
Because it's a combination of two signals.
No. Do you need to solve it. Because this is simple, you can tell. If I make it complex, you cannot tell by just looking at it. Like if it's square root of xt plus, I don't know, x to the power of 2/3, you cannot tell by looking at it. So you need to solve it. I'm giving away exam questions. So add 1.
So yeah,
It's minus xt plus 1. Solve it to see if it's linear or not.
just so I don't get confused. Minus bracket ax1 plus bx2. This is linear.
Minus xt was linear. That was the previous question. Yeah. So previous question, yes, that was linear because we compared these two and they are equal. Now, what I did was I added 1 to it. Now we are dealing with, I'm going to write it here, yt minus xt plus 1. Sorry? No, because as I said, this is a simple, but if it was difficult, like if it was complex, you couldn't just tell it by looking at it. That's why you need to solve it. Yes?
This one, right?
Sorry?
We're still solving this one.
That's close to it. Oh, no, we are solving minus xt plus 1.
Oh, it's
Minus xt. Yes. Back. نه شده سایتشون جدا خواهش کنم we didn't have anyone from this side. So this time it should be someone from this side. Oh no, send me the email. I know your name, but if you don't send me, I forget.
Then in this one we have to apply again this. Like
Which one?
not
Question number 3. 3 looks
No. The reason I didn't solve 3 is that it's a bit complex, and I don't give you something like that in the exam.
but how would you solve
But it's the same. So what you need to do, you don't need to solve
it?
it.
You have to derivate whatever.
No. You don't even need to solve it. So
take this one.
yeah, what you need to do, because
Multiply by just 2 t.
yeah, because that's your output, right?
Uh-huh. That's the output of this
That's
system.
what this system does. If your input will be multiplied by 2t.
Every time I get this, I just have to
Yeah.
The last one.
Yeah.
The right side.
That's just to avoid
This
confusion.
one is not linear.
Why?
This one is going to be plus 2. The other side is just going to be
Plus
1.
1, that's correct. But I want someone from that side to see. Yeah, you didn't send me the email.
Yeah.
Just send.
You were saying like you solve it to one part and then
No. He helps you. So I'm not giving him any bonus marks. You'll get all the 3. That's how he proves that he's a good friend.
I knew that.
سخته؟ Oh, you solved it?
But it's really because when we add two systems with each other, we have 2
Exactly.
plus 1.
Yeah, go solve it.
Really? No.
Yeah, no, that's correct. Go solve it. That's 3 marks. I'll go. No, please. I'll sit here. Minus. Yep, that's correct. Everything is multiplied by minus plus, and then it will be 2 here.
Yeah.
Yep, that's correct. No, so add these, it will be x plus minus bx2 plus 1. Okay, which will be equal to minus ax1 minus bx2 plus 2. Now the second stage. Oh, that's what you did. Now step 2, send ax1 plus bx2 to your system. Okay, and then all this system does is multiply everything by minus 1 and then add 1. So it means multiply everything by minus 1.
This is why it's not linear.
And then
And then
plus 1. Yeah.
Thank you, sir.
Your lecture, remember? So just explain it.
Minus h1 t plus 1 and for the another and the same. So when we add it with each other, we have plus 2. But when we send x1 plus x2 to system, we have minus e plus 1.
Yep, that's correct. And that's not linear. Thank you. So again, send me an email with your name, okay? All right, so if you think about what your system does, you don't get confused. So it doesn't matter what combination I give you in the exam, Just think what it does, and then find the output, compare it. All right, now that was one type of questions you may get. The other type is this. So you may be given a system, and then you will be asked 4 questions. Check if it's memoryless, check if it's causal, check if it's linear, and check if it's time invariant. Now, what I'll do is, I'll go back to the lecture so you can review what we talked about. Because if I go and solve it, then, okay. So here, for checking if a system is time invariant or not, what we did was, first, we shifted the input signal, found the output, then we found the output, and then shifted the output, compare the two, right? So if you look at the first line, we send xn, we delay it, send it to the system, we find the output. At the bottom, we first send the signal to the system and delay the output, and then compare the two, right? So one is shifting the input, the other one is shifting the output. It should result in the same answer. Now, I'll go to linear, we talked about just now. So it should be easy for you to find linear. Remember memoryless systems? So if it depends on the past or future, then your system has memory. And if it only depends on the present, then it doesn't have memory. And then the last one is causal. So if it depends on present and the past, it's causal. If you can find anything in the future, it's not. So this is not in the formula sheet. This is something you need to know, okay? So you need to know when a system is causal, when a system is time invariant, when it's memoryless, and when it's linear. So these 4 items are important. Now, I'll go back to the question. The question is, or the system is, have x, was it minus t? Yeah, minus t. Now, with the same order, we'll go with memoryless, causal, linear, and time invariant. Now, to check the system, first, we'll check the memory. Now, I said the easiest way is just to put time values. So if I put t equal to 2 or t equal to 1, I'll get x minus 2, which is in the past. Or if I put t equal to minus 2, I'll get x 2, which is in the future. So this system has memory. Example is t equal to 2. So y at t equal to 2 is equal to half x minus 2. And because this is in the past, then it has memory. So the other one was causal. So to check if it's causal or not, try to find an input in the future. Can you do that? Can you find an input in the future? What? For what? Negative t, that's correct. So any negative t gives you a value in the future. Example can be t equal to minus 1. So y at minus 1 is equal to half x plus 1. And that's future. So that's not causal. Linearity, by now, you should all be able to tell me. So I'm going to give you just a minute. Quickly see if it's linear or not. It is, or it is not. That's the question. So what I'm running on the left doesn't mean that that's the answer. That's what we are checking, okay? So this one's not memoryless. This one's not causal. To check the linearity, if I send AX1, the answer will be half AX1 minus T. And then if I send BX2, the answer will be half BX2 minus T. And then add them together, you will get half AX1 plus BX2. Now, if I send AX1 plus BX2, I'll get half AX minus T plus BX2 minus T. So these two are equal and they are linear. Because we talked about this a lot, I quickly solved it. And then the last one, time invariant. So I don't have space here, so I'll go and write it here. Y half x minus t. Okay. So again, think what your system does. Send anything, flips multiplied by half. So step one, let's first delay the input, and then in step two, we'll delay the output. So if my xt is the input, and I delay it, what will be the output? xt minus t. And then I send this into my system. And then the output will be? Can you repeat it? Sorry, what did you say? Yeah. That's correct. So again, this is where you get confused if you don't remember what your system does. So whatever goes to the system, the time will be reversed, and then it will be multiplied by half. So I'll write the half. I'll write x, because my only thing which is multiplied by negative sign is time. And my time here is t minus t. So if you multiply t minus t by negative sign or minus 1, the answer will be minus t plus t. All right. Now, in step 2, I first find the answer or the output, and then I delay it. So this time xt, I send it to the system. And then all system does is half it first, and then whatever time I have a negative sign is added. Okay, now I delay it. And then what's the answer? Minus t, that's correct. So it will be x minus t. And these two are not similar or the same. They are similar, they're not the same. So that's not time invariant. Raising hand, who didn't get this? I know this one's a bit tricky.
Can you repeat how it's plus t on the top again?
Okay, sure. So, to explain this, think about time. Don't think about t, okay? Just like when I said, don't think about x and y, think about what your system does. If I say xt, what's your time? It's t, right? If I say xt minus t, what's your time? It's t minus t, right? Because these two are time, but the values are not the same. You know what I mean? So that one's time minus a number. So although the values are not the same, so that if that's xt, that's xt minus t. Okay? So they are both time. Here on the x-axis, that's time. And here, that's time. Okay? Does that make sense? Okay, now we'll go back here. If my system multiplies time by a negative sign, here, that's my time. The whole time gets multiplied by a negative sign. While here, t is my time. So only minus t. No worries. That's the same confusion that happens when you want to change your time domain, okay, in the signal. So if I say, if that's xt, and then if I say I have x alpha t, they're both times, but different time domains, okay? The values are not the same. Think about the example of time here and, for example, in the United States. They're both times, but different values. If it's, I don't know, 6 p.m. here, it's 8 a.m. or 6 a.m. there. The values are different, both are times. Okay, so these two are not equal, and that's why that's not time invariant. Now, the other question, I'll give you, it's 6. The lecture starts at 3:30, right? We have half an hour, so that's good. Just grab a piece of paper. That's a big question, but you already know how to check the linearity. Memoryless and causal, you just need an example to confirm. And item D is a bit tricky, so that's the only part which needs some time. So 5 minutes, see if you can answer all 4 questions, okay? And please don't look at the solution, okay? That's not the proper way of learning it. All right, who's coming to solve it? No one? Okay, so let's start from the first one. Did anyone solve the first one? Item A. Why not?
Because t at any t will be positive, for t is equal to 1.
Yes,
So it will have the negative.
exactly. It will be x minus 1, which depends on the path. Did you solve the second one? What about the second one? It's not? Why not?
Because at t is equal to -1,
Okay.
positive. It will depend on.
Exactly. So if you put t equal to a negative value, it will be positive. That's good. Item C? Not the third one. Okay, solve the third one. That's good. So the first two are correct. So what your friend said is, for the first one, we put t equal to 1, right? And then y1 becomes equal to x minus 1 plus 1. And then here we have an input from past showing that it's not memoryless. The causal part, if you put t equal to a negative value, for example, negative 1, so your y1 becomes equal to x3 plus 1. And that's an item from future. So if you have an input from future, that's not causal. Okay, linearity. It's not linear. Let's see. All right. Who said it's linear? Why? You solve a question about linearity, right? No, it was your friend. Yeah, he solved it. So what do you think? Oh, you think it's linear? Oh, you're solving, so. Okay. So let's see. Okay, so again, look at the system. All it does is changing the time, okay? Because what we see is a change in inside the parentheses. So inside that parentheses is minus 2t plus 1. So time is changing. So if I send ax1 t, what I get is ax minus 2t plus 1 plus 1. And then if I send bx2, I will get bx2 minus 2t plus 1 plus 1. And then if I add these two, I have a component of ab plus 2. Now, if I send ax1 t plus bx2 t to the system, all it changed is time and then adds 1 to the whole input. So first it changes time, right? I'm just changing time to the input, and then I add 1 to it. So that's ax1 plus bx2, that's the input. Just change its time, add 1 to it. That's not linear. Now, item 4. Could anyone solve item D? Who? Yeah, come. This time the mark will be yours. Okay? So yt is x minus 2t. Was it minus 2t or
Yeah, minus 2t.
plus 1
Plus
plus 1? Yep, go for it.
Can I just flip it down?
Yeah, you can. Just explain it. I never came up here. Thank you very much. That's correct. That was the trickiest, I would say, question you can get to check if it's time invariant or not. Now, don't forget the email. Okay, so let me explain what happened here. 2 steps. Step 1, we first delay the input and then send it to the system. Then in step 2, we first send it to the system, then delay the output. It doesn't matter which order you follow. At the end, you will get to the same answer. Yes? Yes? Minus, no, that's correct. It should be minus. Okay, let's solve it. All right, now, all right, minus 2t, yep, you're right. It should be minus 2t plus 2t. Yep, we'll solve it. Yeah, that's correct, because the minus sign gets... All right, now think about time as a concept, not the numbers and letters. So this bit is xt, which is delayed by capital T or tau, so it's xt minus t. Now, consider this as time. So what happens is that time gets multiplied by minus 2 added to 1. So if this is my time, this should be multiplied by 2, by minus 2, and then added to 1, which is what you see down here, except that should be plus. Don't worry, you'll get the full mark. Now, here we first send the input to the system. So if this is my time gets multiplied by minus 2, 1 is added to it, and then I have 1 at the end. Now, it should be delayed The only thing which is delayed is t, or the time you have. So what you get is x minus 2, t minus, Again, think of this as your time. So it will be minus 2t plus 1 minus t, which is delayed. And then that's number 1. And these two are not the same, so it's not time invariant. Questions? All right. That's good. If there is no question,